Hi, my name is Dean Passion, and I am the Director of Advanced Programs at First RF Corporation. Beyond line of sight, or BLOS, communications for the Marine Corps forward elements can be a challenging task. This generally requires satellites for high-speed versions of these kinds of communication links. And foliage is a big issue for SATCOM, especially in triple canopy jungle areas. The Marine Corps asked First RF to investigate alternate methods for making high-speed, beyond line-of-sight communication links possible with the least impact for the operators, size, weight, etc. First RF is in Boulder, Colorado, and we are an 18-year-old small business that develops antennas and RF systems. The company set a single-year record for the number of SBIR wins in the first year of operation, and that record was surpassed several times in later years by First RF. First RF is most well known for the development and production of the Counter Improvised Explosive Device, or IED antenna, that helped save our service members' lives in Afghanistan and Iraq. The invention behind that 301 bandwidth antenna received the Army's top 10 Inventions of the Year award, and these antennas went from Phase 1 SBIR directly into production, and those antennas and a few others have led to the production of more than 250,000 antennas in total at First RF over the last 18 years. The current approach to beyond line of sight communications for the Marine Corps is HF, or high frequency. While HF can provide these types of links to get over the ridge or the hill using near vertical incidence skywave, or NVIS, propagation modes, the data rates are low. To get to higher data rates, satellites or multiple line of sight hops are necessary. Any solution to this type of communication link, i.e. high-speed communication link, needs to be lightweight and portable and have the maximum flexibility to provide high reliability, high-speed communication links in a wide variety of expeditionary situations. The Marine Corps needs high reliability and high-speed communication links. The goal is to have Marine Corps forward elements connect with both the Marine Corps ground network and the Navy afloat networks at sea. The forward elements already have limitations on size, weight, and power, SWAP, as they are generally on foot near their objective. They are often in thick foliage, so propagation paths can be challenging. First RF has created a modular approach to the antenna apertures needed for these line of sight links in order to maximize the flexibility. Each aperture consists of building blocks of panels. The panels can all be used independently, but a modular manifold provides the option of combining multiple panels to form a higher gain, narrower beam width antenna. The panels, each panel can be carried by multiple personnel, such that the increased weight and volume is relatively imperceptible to a single operator. When panels are combined, the higher gain improves the data rate for the link, and the narrower beam width helps minimize the detectability of that link. Operators in forward positions are at the highest risk of exposure when they transmit a signal, and the narrower beam width minimizes the signal level in the direction of the opposing forces. SBIR programs have a natural progression. This modular panel antenna concept was initially developed in Phase 1, and we've already had the opportunity for early testing at ANTX. We're working to use the feedback from that testing opportunity to make improvements during the remainder of our current Phase 2 effort. Some of the benefits you see listed on this slide have been discussed previously, but we have not covered a couple of them very well. The modularity helps with the logistics of packing and using the pieces. Since the arrays are broadband, they actually work with a variety of radios, and this means the Marine Corps can use what they have. In other words, we're not developing an antenna that requires you to go out and develop a radio. The primary goal for this effort is high data rates in beyond line of sight BLOS communication links. But the secondary aspects of the approach might be the most important. A high-speed link does not need to transmit for as long a duration as a low-speed link. This not only reduces the exposure of the operators to detection, but it also tends to save power. And by saving power, we're saving the required weight of batteries. And battery weight, as you can probably guess, is one of the most tough logistical challenges faced by these forward teams. The radio market is quickly moving to software-defined radio, SDR, technology. And a typical SDR covers a very wide band frequency range. As an antenna engineer, one of the things I hear regularly is that the radio can do everything, so why can't I get an antenna that can match what the radio can do? Antennas, however, are limited by physics more than current state of technology. In other words, we can't just make the antenna smaller because technology got better, like we can do with a lot of the electronics. But as we've shown at First RF, antenna engineers haven't been pushing close enough to those physical limits. The FRF 105D antennas shown on the MRAPs in the picture on this slide operate over a 300-to-1 bandwidth, and almost no one thought that was possible for an omnidirectional antenna. The developments on this program for high-speed beyond line-of-sight communications for the Marine Corps will be able to tap into the same SDR market because these antennas are also very wide band and therefore able to work with a wide variety of radios, transceivers, etc. Any operators working at a tactical level can benefit from the modularity and portability of the antenna hardware solution for these types of non-line-of-sight communication links. And this includes civilian uses as well. The ability to build a wideband antenna of whatever size is needed while deployed is an advantage to all users. I want to thank you for listening to this presentation, and I am happy to be able to talk about this practical and modular antenna system that supports high data rate communications in line of sight and beyond line of sight roles. First RF is a small business with an amazing ability to meet really tough antenna challenges. Lars or I will be happy to talk with you further about any opportunities to use these antennas to get the most out of modern wideband radio systems.